So today we are going to be multiplying a monomial by polynomials. Monomial being one term, polynomials being more than one term. And we've got a couple different things that we need to remember here. We need to remember distribution. You've been distributing a long time. Then we need to think back to last unit when we were multiplying exponents. We are going to add them. So when we are multiplying, we add the exponents. We are going to distribute. Here we have negative 2x multiplied by this term here, 3x squared minus 4x plus 5. And we need to multiply the negative 2x by each term of this polynomial. And we do so by multiplication. I'm going to write it piece by piece a couple of times, and then I will kind of back off of that, but you're welcome to do whatever you feel comfortable doing. So we're going to do the negative 2x times this first term, 3x squared. Then the minus 2x times negative 4x. Then minus 2x times 5. Then I need to multiply with the same rules we followed last unit. Please remember that if there's no exponent on your variable, it's a 1. I'm afraid that if I write that in, it's going to look really terrible. So the negative 2 times 3 is negative 6. X to the 1, I'm going to write it piece by piece, plus x squared. Then I'm going to look at my next pieces. Negative 2 times negative 4 is positive 8. Then x to the 1 plus x to the 1. And lastly, negative 2 times negative 2 is positive 4. What am I doing? Sorry. Negative 2 times 5 is negative 5. And then x to the 1 with no x term here. Now I can go ahead and just add my exponents. And I am breaking this down very piece by piece. This is what we did last unit. I'm not going to do this part again. So we get negative 6x to the third, 8x squared, because 1 plus 1, minus 5x. Please remember, I don't write the 1 if it's just a 1. That's not what mathematicians do. And that is your final answer. All right, so example number 1, we just have x to the 1. And that's what I'm going to distribute across my parentheses. One more time, I'm going to write it out. So we've got x times 7x squared plus x times 4. Here I'm going to add my exponents. So 7 times 1 is 7. X to the 1 plus 2. So 1 plus 2. And then on this side we've got 4 times x, which is just 4x. And then I need to add my exponents. 7x to the third plus 4x. Number 2, we have a negative. The negatives always just add another level of complexity to keep track of. So watch your signs here. Negative 2x squared times negative 5. Minus 2x squared times negative 7x. Negative 2 times negative 5 is positive 10x squared. No x term on our 5. Negative 2 times negative 7 is plus 14. X to the 2 plus 1 is x to the third. 10x squared plus 14x to the third. Number 3, we are distributing a 3v in 3 terms. 3 times 8, 24. V to the 1 plus v squared is v to the third. 3v times v, we just have our 3, and then v1 plus 1 is v squared. And then lastly, 3 times negative 3 is negative 9, and we have our v, there's no v on that term there. So we have 24 v to the third plus 3v squared minus 9v. Number 4. Five times 2 is 10. Then we look at our x terms. We've got x squared times x squared, so x2 plus 2, which is x to the fourth. 5 times 2 is 10, and x squared times x is x to the 2 plus 1, so x to the third. And lastly, 5 times 3 is 15. We have no x term here, so we just have x squared. Okay. Next, we're going to multiply 2 polynomials. So we've got a 2 term times a 2 term. And we are going to do distribution. You just have to distribute more than once. So first, I'm going to take this first term of my first set of parentheses, the 2x, and I'm going to multiply it by the 3 and then by the negative 2x. So, and I'm going to break this down into pieces again. I have 2x times 3 plus 2x times negative 2x. Then, should have left a little bit more room. Then we're going to take the second piece of our first set of parentheses and multiply it by the 3 and by the negative 2x. So negative 3 times 3, negative 3 times negative 2x. So then again, I'm going to multiply my numbers, and I'm going to use my rules for multiplying exponents by adding my exponents. 2 times 3 is 6. I only have one x. Here I have 2 times negative 2, so negative 4. X to the 1 plus 1, x squared. This is very messy. That shouldn't have a parenthesis there. Negative 3 times 3 is negative 9. There are no x terms on this one. Then negative 3 times negative 2 is positive 6, and we only have that x term. Now, when you do this process, you're going to end up with like terms, and you have to combine those like terms, which is what we did yesterday. So I have an x term, and I have an x term. So I need to combine those. Now, we will do a lot of these, and this is where you're going to see them written in order of power of exponent. So my biggest exponent here is x squared. So I'm just going to bring this for negative 4x squared down first. And I've got these two x terms, and I need to combine them by adding. 6x plus 6x is plus 12x. And then I just have this negative 9. So I don't give myself a lot of room, but negative 4x squared plus 12x minus 9. And we will do a lot of these. This is this process that I would practice and practice. Here, remember, we're going to distribute both terms of the first set of parentheses to both terms of the second set. So 3n times 2n plus 3n times 7. 3n times 2n plus 3n times 7. Then you have to do your second piece. 3 times 2n and 3 times 7. So plus 3 times 2n plus 3 times 7. Multiply numbers, add your exponents. 3 times 2 is 6. n1 plus 1 is n squared. 3 times 7 plus 21, we only have an n term here. 3 times 2 is 6, and 1 n term. And 3 times 7, which is just 21. We're already arranged in order of exponent, but we have 2 n terms that we can bring together. So 6n squared plus 21 plus 6, 27n plus 2. Please remember, when you add terms, you're not changing the power of your variable. Number 2. 3k times k, 3k times negative 3. 3k plus 3k times negative 3. And then your second term, negative 5 times k, negative 5 times negative 3. So negative 5 times k, negative 5 times negative 3. 3 times 1 is 3. K1 plus 1 is k squared. 3 times negative 3 is negative 9. I only have that one k term. Negative 5 times 1 is just negative 5 and just single k. And then negative 5 times negative 3 is plus 15. Last step, we need to combine our 2k terms. 3k squared minus 14k plus 15. Up it one more time. A binomial by a trinomial. Same exact process, you just have more terms to distribute and then also to combine. So the 6x is going to multiply by all 3 terms like we did on the front. And then I'm going to go ahead and fill this in. Then we're going to take the negative 2x by all 3 terms. So 6x times x squared plus 6x times negative 7x plus 6x times negative 2. And then our bottom, our negative 2. Negative 2 times x squared minus 2 times negative 7x. Oh my gosh, I'm remembering. And then negative 2 times negative 2. Six times 1 is 6. X to the 1 plus 2 is x to the third. 6 times negative 7, negative 42. x1 plus 1 is x squared. 6 times negative 2, we only have a single x term. Negative 2 times x squared is just negative 2x squared. Negative 2 times negative 7 is plus 14, single x. And then negative 2 times negative 2 is plus 4. Now, we do also have more like terms to combine. I'm going to keep the 6x to the third first because it's the highest exponent. Then I have 2x squared terms. So negative 42x squared minus 2x squared is negative 44x squared. And then I've got 2x terms. Negative 12x plus 14x is plus 2x plus 4. So same exact thing, you just have an extra step of distributing in both the top set and the bottom set. I'm going to try to condense this a little bit more. I'm not going to write down every single step. So 6v times all three pieces, and then 3 times all three pieces. 6 times 2 is 12. v1 times v2 is v to the third. Then 6v times 3v. 6 times 3, v to the 1 times v to the 1 is v squared. And lastly, 6v times 8, 48, and a single v. Now I need to go to this green lower part. I'm going to distribute the 3 across the second set of parentheses. So plus 3 times 2 is 6, v squared. 3 times 3v plus 9v, and then 3 times 8. Last step, look for like terms, which we do have. I'm going to bring down the 12v to the third. That's the highest exponent. There's only one of them. I've got 18v squared plus 6v squared plus 24v squared. Then I have plus 48v plus 9v plus 57v, and my plus 24 at the end. All right, last thing. Perfect square trinomials. So there are some what we call special case situations where we can have sort of little cheats that are make it super fast just to get the right answer. And perfect square trinomials is one of our special cases. Quantity a plus b squared, when you were to, this is what we're looking at. If you have a binomial times a binomial, but your pieces are the same, your a's are the same, your b's are the same, you write it like this. And instead of having to distribute, you can do it without distributing, because there's this cheat. You can say a squared plus 2 times a times b plus b squared. So, you know me, I think examples are much easier. Here we've got x, you could call that our a term, and then b term would be the negative 6. And that needs to be a plus. So that's wrong. That needs to be a plus there. Then we're going to say a squared, or a is x, so x squared, plus 2 times a times b, so 2 times x times 6, plus b squared. b is 6. So plus 6 squared. Then we just do the math. X squared plus 2 times 6 is 12x, because we have x there, plus 6 squared is 36. So this is much faster than, I don't know where my other sheet went, than, you know, doing that. And it gets to the point where you can do this in your head. Same thing here, a and b, if you want to write it out, so a is equal to 6v, and b is equal to 3. So a squared, parentheses. Please remember, I talk about parentheses constantly. The a term is 6v. If you don't square that 6, it's going to be wrong. So you have to make sure that you're watching your parentheses. Plus 2 times a, which is 6v, times b, which is 3, plus b squared, which is 3 squared. Again, you have to multiply that, you have to square that 6. That's part of the a squared. 36v squared. Here we have 2 times 6 times 3, so plus 36, and we have a v here, plus not 3 squared is 9. 36v squared plus 36v plus 9. And that is multiplying polynomials using the distributive property.